So this is the last part of section 1.7, talking about precision versus accuracy. In science, we use them very particularly, and they mean different things. And this will become more important in lab. So accuracy is referring to how close the measured value is to the actual or true value. How correct is it? Precision refers to, well, if I make a bunch of measurements, how close are they to each other? How reproducible are they? So here's some results from 3 students weighing a block of lead that weighs 10 grams. And from the table, it's really hard to tell what we're looking at there. This is why scientists like to graph things, because it allows us to see what's going on. So these are just bar graphs for each student. So here's the mass of the block, and here's a bar representing the mass of the first trial, the first time, the second time, the third time, the fourth time. And so what we can see is that the bars on this one are all over the place, where the bars on this one are almost all the same, and these almost all the same. So this is precise, and this one is precise. This is not precise. It's not reproducible. It's all over the place. To look at the accuracy, we're going to average the numbers and see how close it is to the correct value. So the dotted line here is the average. So this average is 10.13. The true mass was 10. Here, the average is 9.79. So here it's lower, there it's higher. Here, the average is 10.01, which is very close to 10, right? So this one is accurate and precise. This one is inaccurate but precise, and that one is none of them. We try to get accurate and precise. That's what we're going for. So why would those results be inaccurate or imprecise? There are 2 main causes of error. One is random error. Every time you take a measurement, there's a chance that your measurement is going to be a little too high or a little too low, because no measurement is exact. Very frustrating, but it's not exact. So it has an equal probability of being too high or too low. So we can get rid of that by making a bunch of measurements and averaging them, because the too high and the too low will cancel each other out. So that's why you'll see in lab we often do things 4 times, because then we can average them. Systematic error is an error that tends to be either too high or too low, and this can be because the instrument has a problem, or because you're using the instrument incorrectly, or maybe when you're weighing your bananas at the grocery store, somebody has their thumb on the balance, right? They're going to weigh high every time if you've got your thumb on there, right? So that's a systematic error. Those can't be taken care of by making multiple measurements, but we can think about it and try to eliminate those.